You are welcome to PECO Virtual School. Today we are going to look at the computer or ICT. The person going to handle the lesson at this time is Mr. Kichui Shadrack Enoch. Now, before you start watching, remember there are previous parts in this topic. We are dealing with the hardware, but already there are other parts which have been taught previously, so ensure that you seek to watch part 1, part 2, part 3, and then you come to this part. Right? Now, we are going to look at, in the hardware part, we are going to look at the microcomputer system unit. Microcomputer system unit, or let's in short say the system unit. Now, what is the system unit? The system unit. When we talk of the system unit alone, when we talk of the system unit alone, the system unit is the box cabinet that contain several components within it, which may include the hard disk, the motherboard, and other components. Now, the system unit or cabinet contains the following components, which we need to know. We have the power supply. The power supply, which is found within the system unit. We have the motherboard. We have the hard disk drive. We have the system clock, RAM and ROM chips, expansion slots, and board. Now, what does it mean? You may be told to identify devices that are found within the system unit. You may be told to identify or to list the devices which are found on or within the system unit. Devices which are found within the system unit. So simply you'll say within the system unit we have the power supply, we have the motherboard, we have the hard drive, system clock, RAM and ROM chips or random access memory and read-only memory chips, expansion slots and boards, and bus lines. But these are basic components, but there are several others. These are basic components that can be identified within the system unit, but there are several others. Now, in picture, when you are to use your computer, usually you will see this huge box, especially in a microcomputer or the desktop computer. When you talk of a desktop computer, you will see this box here. Now, when you open this box, when you open it, you will see components within. If you open, within their components which are identifiable, you can easily pull out any component, and there you will see the power supply within there. You will see other chips. A fan will be there. Actually, I didn't list a fan here, but the fact is there is also a fan. Now, when we talk of when we are trying to look at the explanation, further explanation, before we continue that, you need to know that there are important books that you can use for your own revision, where you can read, you can find questions to attempt, questions and answers, or books which can facilitate in your practical work. Here we have computer studies O level. It is found in several bookshops around Uganda, including Kampala. This is for O level, where you have all the computer studies notes, questions and answers, and also you will find UNEB questions and answer approach. Here we have the direct points. This book is known as the bulldozer. The bulldozer. This one is for practical. All the step-by-step practical work is here. Oh, they are all included here in all the packages. But there is another book called Elementary Programming and Web Design, still for direct point. This book has computer programming using C and HTML. This applies at O level, but also it is a good book when you want to start programming. Always, if you are planning to study computer programming later, please don't hesitate to get this book even after your work of Senior 4, even after of Form 6, to start preparing programming. Else, you will be among the students who finish university and hire people to do for them computer programming because they don't know how to program. But this book will introduce good programming for you. And lastly, we have direct points, a book known as the Examiner's Words, having all the notes for A-level students. It has all the topics, questions in each and every topic, and also at the end there are mock questions which are answered, and also UNEB questions which are answered. It is very beneficial to you. Now, here it shows all the levels that are there. Now, let's look at power supply. Power supply. Pictorially, power supply, you will find it looking like this. Within, when you open your system unit, you will find a power supply there. This power supply, that's why you plug the cable. You plug the cable from the wall, that cable, power cable, which is fixed on the wall socket. The power directly is brought to the power supply. The power is directly brought to the power supply. At times you can find it in this shape because once it receives the power from the wall socket, the electric wall socket that you plug your cable to the computer will always come to the power supply, and this power supply will collect that power and regulate it to have that power run computer components, because computer components run on power. And these several cables you see from the power supply will now supply electric power to the rest of computer components. So we can look at the role of the power supply, and we'll say the power supply is the device that convert alternating current, or AC. When we talk about alternating current, it converts alternating current, known as AC, to direct current DC to run the computer. To run the computer. That means this alternating current, when we say alternating, we mean the current that is not constant. It alternates. It keep on changing. At times it is too high or too low. Now that power can hardly run the computer, but when that power is converted to direct current, this power can easily run computer components. Else, if it is allowed to go straight to internal computer components, they can be blown out because they can't sustain that power. But the power supply has to be used to convert and make that power sustainable by the computer. So the electric available from a standard wall outlet is alternating current and can cause harm to the computer. That's why we have the power supply. That power supply, its work is to supply power which is in a direct current form. The on-off switch, that is on your wall circuit, where you plug even when you want to iron your clothes. When you want to iron your clothes, you plug there. Or even when you want to cook, you can also get the electric cooker and plug there. That where you plug, it is an on-off switch. It is a wall socket. In your computer, turns on or shuts off the electricity to the power supply. Okay, that wall circuit there, when you turn it on or off, it supplies the current to the power supply, or when you switch it off, it stops supplying. So because electric can generate a lot of heat, that electricity can always generate a lot of heat, a lot of it. So there is a fan. There is a fan there for cooling, to ensure that internal computer components don't overheat. So you always have a fan there. Much as the power supply has regulated that power which is to run the computer, but the fan will regulate. Usually when you open your machine, inside you'll find a very high speed spinning, something spinning there, distributing some cool air. That is the fan. So we say because electricity can generate a lot of heat, a fan inside the computer keeps the power supply and the other components from becoming too hot. Because if that fan fails to work and the machine starts generating a lot of heat, then most internal components can start getting troubled. Now, the other internal component found in the system unit visibly is the motherboard. Now, motherboard is not a single functional device. It is not, you can't really say that motherboard is doing a particular role apart from holding several components that are within the system unit. So the motherboard is spread, it's broadly occupying the system unit. When you open, actually it almost cover the one of the bottoms. When you open that box cabinet, one of the bottoms of that box cabinet is seated a motherboard. Now it is on this board where several components are mounted. Okay, here they tried to show you there are so many Apart from basic components, we know we shall find that there is a fan, heat sink, mounting points, CPU sockets, okay, connectors for integrated peripherals, because there are several peripherals which are connected within. CMOS backup battery is also there, PCI slot, and several others. We can't label all, and they will all found within the motherboard. And to remind you, most of electronic devices like a TV, like a phone, a smartphone, they have a motherboard where there are small components mounted on there. So it's not only microcomputer, but several other devices have motherboard. But here we're talking of this motherboard of a microcomputer. But you'll find that there are several components which are there. There are so many components, and you'll find each component perform different tasks, but they are stationed there on the motherboard. So by definition, you can say a motherboard or system board, at times it's called the system board. The motherboard or system board, but the motherboard is most common, is the main printed flat circuit. We call it flat because it is spread there at the bottom. Flat circuit board in an electric device such as microcomputer, because there are other electric devices apart from microcomputers which have motherboard, but here we say a motherboard or system board is the main printed flat circuit. Why do we say main printed flat circuit board? There are other smaller board, other like a card, it is also printed circuit within the motherboard, but this one will say it's the main printed flat circuit board in an electronic device such as a microcomputer. Now, the board contains expansion slots or sockets that accept additional boards or expansion cards. In a microcomputer, the motherboard contains the microprocessor. That means microprocessor is there, even the primary storage, primary or main memory, or at times we can call it random access memory, is there. So there is a microprocessor. Microprocessor is found there on the motherboard. These are basic components. Now these ones also, there is a primary storage chips, or can you say memory cards. Also there are buses. We shall look at the buses, and all the chips used for controlling peripherals. You know, what are peripherals? If I'm to remind you, they are peripheral devices which are connected to the computer, to that system unit, which can be a printer, can be a keyboard, can be a mouse, and all other devices that are attached to the computer are known as the peripheral devices. Now, when you have all these peripheral devices, they need a controller. So these controllers are particular chips defined on how to control the the peripheral devices. Now, these chips are also within the motherboard. Now, let us look at the hard drive. Hard drive, which is also found within the motherboard. And the hard drive, of course, we learned it on the previous presentations, and we really did a lot of explanation there. But I simply want to tell you that it's one of the components within the system unit. And the hard drive, or the hard disk is for storing large amount of information. So you'll find here is just a picture of a hard disk. When you open, if you are to open your system unit or the system board, when you open that system unit, you will find the hard disk there. So here I'm just showing you, but previously we talked about the hard disk. Now, within the system unit, we also have expansion slots and board. Expansion slots and board. But this one, where do you get them? They are also mounted on the motherboard. Okay, we just say that they are within the system unit, but also they are mounted there on the motherboard. This is still the motherboard. It is still the motherboard, but you'll find that these one are called expansion slots and board. You can even hear expansion slots and board. Now, why? Because if the computer can be given several, or its capacity can be expanded. Its capacity can be expanded. How? Sometimes you may have memory, but you may need to have more memory capacity on your machine. So apart from the memory which is there, you can purchase another memory chip and you fix and expand your memory. That's why they call it expansion slotted board. But you can have other, you may require to gain more capacity of your processor. Maybe you may want to have a network card. A network card which can allow your computer to be connected to the internet or to the network, any network. So you can get that extra card and slot in. That's what they call it, expansion slots and board. But not only that, there are other several capacities, including the TV card. You may want to watch TV on your computer, to act just like your normal television. So you purchase that card and you expand the capacity of your machine. So plus several other functions that you may find that your machine, when you are purchasing, didn't have. Then you go and add. Otherwise, if they were to add all of them and you don't need them, your machine can turn out to be very expensive. Yet there are some components you may not need them. You may not be in need of a network card to use a network. You may not in need of watching TV using your laptop or your computer. And with that, they will not be there. But you can purchase extra cards and slot in them. That's what they call it, expansion slots and board. So these are part of the cards you can buy, like this one, memory cards or RAM chips, whereby you may want to get any and fix them here, slot them to expand the memory capacity. Down here it shows here a finger holding the card, trying to fix it. Trying to fix, meaning that you are adding more capacity, you are inserting the card's extra memory capacity to your machine. The memory is in capacity. It can be 1 GB, but you may want it to be 4 GB. So you purchase extra memory and you add on. Now, expansion slots and board. Expansion slots and board, we say, are sockets. We are still explaining now the actual definition that expansion slots are sockets on the motherboard into which you can plug expansion cards, where I showed you that you can get there are slots, and we call them sockets, whereby they are there on the motherboard. Those sockets are there on the motherboard, where you can easily plug expansion cards. So these expansion cards we are talking about are found, can be slotted on those sockets, which are found on the motherboard. Look at the motherboard behind there. So expansion cards or add-on boards, the other name are add-on boards. So can say that expansion cards or add-on boards, the board that you can add, those expansion cards, you can also call them add-on boards, are circuit boards that provide more memory or more control peripheral devices. Okay, meaning that if you are to add a card, that expansion card, you may be adding or providing more memory to your machine, so that your machine can store more information during processing. But you can also add the capacity of the control devices or peripheral devices for any purpose, practical purposes, I mean. Now, among the types of expansion cards are the following. Among the types of expansion cards, among the types are, you may have expanded memory. That means you may expand memory. These are just a few, but there are so many. Memory expansion cards allow you to add RAM chips, giving you more memory space. That's what we call expanded memory. You want to have more memory space. It's like you have a store, but you want to expand it. You want to expand it so that you can store more things. But also there is a display adapter. Now the display adapter, these cards allow you to adapt different kinds of color video display monitor for your computer. So you may want to have a better display on your monitor screen, so you may add more graphic cards, and say you can add more display adapter card within your machine, so that you can be able to do or to display better video colors on your machine. Then come to other adds-on. That means others, because there can be many. Say you can also add special circuit boards for modem. Modem. There is a device called modem. This modem we shall study later, but it's kind of a device that can convert analog data coming from the telephone line outside the computer into digital, because computer uses digital data. So the modem is kind of a device that converts. So it has to be fixed. But there is also fax, sound, and network cards can also be added. Fax is the small device. That card can aid your machine to be able to run a fax machine. So, and also sound and network cards. All these when you anything that you are doing in a computer, it must have a special chip that is in charge of controlling. So when you are trying to do faxing is a kind of transmission of information, where you use a device, the device called the fax machine. That means then the machine must have that fax card, sound card if you are to play sound, or it may be network cards if you want to connect to the network, as well as math. When you are to perform a lot of calculation, you need a particular card for performing such calculations. The more complicated mathematics you are to handle, then the math card must be there. Graphic cards, graphics, when you have to deal with very powerful graphics, maybe for playing, at times playing very powerful games, you need a special card which can manage to process that. Then there is what we call bus lines. Now a bus line, or simply bus, we learned before actually that these are channels, is an electrical pathway through which bits are transmitted within the CPU and other devices in the system unit. Okay. Now remember that bus lines are part of the components found within the system unit. They are part of the components found within the system unit, but this one aids in transportation of data. The bus lines aids in the transportation of data from one computer component to another, maybe from memory to CPU, from CPU to hard disk. So you need the bus. That's why I say a bus line, or simply a bus, is an electrical pathway through which bits are transmitted within the CPU and are the devices in the system unit. Bits are small units of data items. These small units that are transmitted from one device to another represents data files. A file is transmitted from one component to the other. They are transmitted in form of bits. Bits are small data units. Now, the different types of bus line include address bus. We have control bus and data bus. Keenly note these three different bus lines. That it can be address bus. It means the address bus is dedicated for transmitting the address of a particular data item to be transmitted. Also, control bus are only used to convey commands. When the control unit tries to issue commands that is directed to particular device on what to do, then the control bus will be in charge of that, and the data bus will be transporting the actual data material that are transported from one device to another. So you need to know the differences as we are going to look at. So address bus is an internal channel from the CPU to memory. It's an internal channel from the CPU to memory, across which the addresses of data, not the data, but address of data. Now, you should know that when these data items are stored within the computer, when they are stored, the location which they are stored are addressed. They are addressed. It's like you, when you are in school, the room that you sit when you are studying, it is having an address. The school create an address. Can call it Senior 2 East, or Senior 2 West, or Senior 2A, or Senior 2B. That becomes the address of that room. When you go to staff room, they can also write that this is the staff room, and they can, if there are several staff room, they can give them numbers. Those one becomes the address. But things which are within can be compared to data. When you go to hospital, you'll find the rooms are numbered. Or when you go to any building, maybe in a flat form, the rooms will be given floor numbers. Each floor, ground floor, first floor, then room number. Those becomes the address of those rooms, so that when you are to be directed, you can easily follow that you are in third floor, but which room number. So that one becomes the address of that room. So even these data items within the memory, they don't just go at random and occupy anyhow. No, they will occupy particular locations, and these locations have numbers, and the number we are talking about are the addresses. Now, because of that, when you are to access any data item, you access it using its address. Like even you, when you are in school, if someone is to direct how best you can be located, they will say go to Senior 2 West, and someone can follow reading the classroom numbers until it's locating you. So even in these channels, there are dedicated channels called the address bus for transmitting these addresses for accessing data item. So the number of lines or wires in the address bus determines the amount of memory that can be directly addressed, as each line carries 1 bit of the address. That means you also need several channels for the address only, in case you are to access several data items on your memory. Then let's look at control bus. Control. You know what the control mean. To control, of course, is to oversee, to oversee how things are being done, to give command and so on. So computer will keep on issuing commands to several devices on what to do, and usually this work done by the control unit. So is a computer bus, we are looking at the control bus, is a computer bus that is used by the CPU to communicate with the devices that are contained within the computer. This occurs through physical connections such as cables or printed circuits. Cables or printed circuits. That is a computer bus that is used by the CPU to communicate with the devices. To communicate, this word to communicate, to communicate with the what? With the devices. That means the CPU communicates with the devices, but when it communicates with the devices, always it gives the control commands. Okay, and the channel that it uses is called the control bus. So it's a computer bus that is used by the CPU to communicate with the devices that are contained within the computer. So this occurs through physical connections such as cables or printed circuits. Cables or printed circuits. And the purpose of these channels is to have the CPU or control unit, because it is within the CPU, when it is trying to send signals to different devices indicating it on what to do. Now, it is the control bus that regulates which direction the write and read information needed to go. It is the control bus that regulates which direction the write and read information needed to go. Okay, because there might be several directions. The write may be writing on memory. The write may be writing on a hard disk. The write may be writing on registers, and so on. But the control bus will regulate that. So the control bus contains a control line for write instructions and a control line for read instructions, because the instruction may be write on when you are sending, or when you are reading, receiving from another device. So let's look at data bus. An internal channel that carries data between a computer's central processing unit and its random access memory. Okay, it is an internal channel. That data bus, it's an internal channel that carries data between computer's central processing unit, or the CPU, and its random access memory. So data will always travel from the CPU to random access memory. So random access memory contains data to be processed, but the processor is the CPU, or the central processing unit. So in between, data items will keep on traveling back and forth from CPU to random access memory. When the data items move from random access memory to CPU, they are in form of data, raw data. But when they are brought back, they are in form of results, because they have been processed. Now they come back to random access memory, ready for writing on hard disk as a feedback, or even sending them to any of the output devices like a printer or the monitor screen where you can always view. That's how things work. And right now you can keep on having those basic understanding, and later on you'll keep on adding more knowledge about data buses. Now, here we have a simple diagram showing the control bus, that address bus, and the data bus. Okay, control, address, and data buses. Look at it here. Usually you'll have the memory, which at times you can refer to as the primary memory or random access memory. So within here there is also a central processing unit. So they show you that there is the address bus, whereby that channel alone can aid the address of particular memory or the particular location of the main memory to be ready, or rather, when the CPU is accessing any data item, it accesses it based on the address. It knows all the address locations in this huge room, which you can call it main memory, whereby there are small memory locations, and those small memory locations are numbered, and those numbers are referred to as the addresses. So we need the address bus for accessing, for sending a message to a particular location which is addressed when we want to access a data item for processing. And when the particular data now is to come for processing, it will follow the data bus. Here the central process unit is, you will realize that memory doesn't control the CPU. But here, since the central processing unit is the one to access something here, it will use the address bus. But when the actual data is located, it will use the data bus to go to central processing unit for processing, but it will also use the same to come as a feedback to main memory. Then we have control bus, which provides control to different components within the machine. Then let's look at the system clock. A computer has a clock. When you open your system unit, you will find there is a system clock within the system clock, and that clock, there is a battery there that runs that clock even when the power is off. So what is this system clock for? All devices that are working within the computer are timed. They are supposed to complete a task within a particular duration, because the machine works with the capacity. It is measured that with this particular capacity, a task can be completed at a particular duration. So you always need a system clock which can synchronize the operation of those components, because those components are working together. They are working together, and so they are timed. and the system clock is just doing that. So we say a system clock is a device that generates periodic, accurately spaced signals used for several purposes, such as the regulation of the operations of a processor or generation of interrupts. Now, we say that the clock is a device. It is a device that generates periodic, accurately spaced signals. They are periodic, things which come after a particular interval, that and accurately spaced signals. Accurately spaced signals used for several purposes, such as the regulation of the operations of the processor. So the processor, it performs, but its performance is expected to end at a particular time interval. And now that it works with several other components within the machine, the computer, you will find that it is the system clock that determines the odd timing, to find out that with this particular time we expect this operation to be complete, and again with this other particular time we expect this operation to be complete. So that is the work of the system clock, that is trying to handle that. The computer does not just work anyhow, but they are timed. Components are timed. They are synchronized to work together, and it is based on that timing using the system clock. So the system clock controls the speed of all the operations within a computer. Actually, this can be the best definition you can use, that the system clock controls the speed of all the operations within the computer. So the clock speed is the internal speed of a computer. That is clock speed. Clock speed, the way it, because the clock moves, it does some timing, is the internal speed of a computer. Okay, now the clock speed is expressed in megahertz, or you can say 33 megahertz means 33 million cycle per second. But it can also be in gigahertz. With a computer which operates at a very high speed, can be in gigahertz, and so on. A computer processor's speed is faster if it has higher clock speed. That means that unless the clock speed is higher, you can't say your computer has a very high speed. So we say that your computer processor's speed is faster if it has the higher clock speed. So the two must be coming together, and that is, clock must be able to move very fast, because the unit of time may also be not only in megahertz, it can be in gigahertz, determine that that computer can operate at a very high speed. So the clock, since it is timing, it must, the way it time, the way it synchronizes the devices, it will also determine the nature of the processor's speed. Now let's look at the ports. Ports are also found within that very system unit, where you can do some plug-in. A port is a socket on the outside of the system unit. It is a socket where it can allow you to plug in something on the outside of the system unit. That is connected to an expansion board on the inside of the system unit. That means that port, it is a socket outside of the system unit, outside, that is connected to an expansion board on the inside of the system unit. That means on the inside of the system unit, when that port, when you connect anything to that port, it will connect to the expansion slot inside now to that motherboard within the system unit, where the expansion slots within the motherboard, where you connect that port outside. If it is controlling maybe the printer, when you are connecting, you will use that port, that socket outside the system unit. But when it communicates to the computer, you will use the expansion slot and body there to fix, so that it can communicate with the internal components. Now, a port allows you to plug in a cable to connect a peripheral device, such as a monitor, printer, modem, etc., so that it can communicate with a computer system. So outside, when you have your external device, a peripheral device like a printer, you will simply use the external port and fix your port there. Assume this is the system unit, but if you want to connect anything, there will be a port here and there will be a cable. So if this is a printer, from outside you will connect, but from inside, there you will have now the motherboard. You will have the motherboard around here, and there must be expansion slot where you can fix something there, where you can connect and link together. So this card here, it means will be in charge of controlling the printer, as we saw the motherboard previously. So the printer needs also a special card to control that, to control it as a peripheral device. Now we say ports are of 5 types. Not only 5 types, there are many, but you can look at the major parts, major ports. We have parallel ports, that this allows lines to be connected that will enable 8 bits to be transmitted simultaneously, called parallel ports. Parallel lines move information faster than serial lines do, but they can transmit information efficiently within a very short distance. So parallel ports are used mostly for connecting printers. So just know that they are what you call parallel ports, which can allow 8 bits to move at once. But this other one called serial ports, the difference we should know that a serial port enables a line to be connected that will send bits one at a time on a single line. So while this one moves 8 bits at once, the parallel ports, the serial ports, moves one at a time, one bit at a time. So on a single line. That means here they will be parallel. So 8 lines parallel, allowing 8 bits to move, but on serial it will be just one single line, allowing bits to move one at a time. So serial port is slower than parallel ports. It is slower. Why? It can only allow one bit at a time. Parallel ports are faster because they allow 8 bits at a time. But of course, they function differently because parallel ports basically they are used to communicate when the computer communicates with the printer. Okay, but the serial port is slower. Now, however, serial ports can allow information to be transmitted to longer distance. Unlike parallel ports, which can only communicate within a short distance, serial ports can allow information to be transmitted to long distances. Serial ports are used principally for communication lines like modems and mice. Modem and mice. That means a mouse uses serial port, but also the modems. But when you talk of the modem, it will convert that information which will follow the network, of which the network can continue to the telephone lines, which can create that information move covering the long distance. We also have what we call USB port. USB port, or in USB stands for Universal Serial Bus. Universal Serial Bus is a type of port that allows you to connect several different devices using only one port. That means when you have a USB which is universal, several type of devices can be connected. You can have a printer using USB. You can have a phone using USB. You can have external hard disk using a USB to connect to the computer. That's what they call it, is USB. For example, you can use a USB port to connect the printer, modem, joystick, scanner, and many others. Then you have what we call video adapter port. These are used to connect the video display monitor outside the computer to the video adapter card inside the system unit. Can connect also that video adapter port. But you have game port for game. Basically for game. Game port allows you to attach a joystick or similar game playing devices to the system unit. Now, here we have a simple diagram showing the system unit and several ports outside there. Like here we have the printer port, that's the parallel port we're talking about. Ethernet port, these are usually for network. PS for mice, PS for keyboard. May connect here a mouse, a keyboard. Here usually you can fix your mouse, you can fix your keyboard. USB, you can put there a flash, you can put there also a printer. Serial port for modem, okay, you can fix for modem there. VGA port and so many others. You can even connect there the speakers. You can have your speaker connected here. Line in for other connection, microphones can be connected there. Game port. So there are several depending on, and they keep on advancing. Like this one is the old model. This CPU unit is of old model, but all these ports are still found in modern machines. They are still found, but when you have again new models, you will find several other ports. Now, microprocessor. A microprocessor, or the CPU, is also found within the very system unit. A microprocessor is a computer processor that incorporates the functions of computer's central processing unit on a single integrated circuit. Okay? A microprocessor is a computer processor that incorporates the functions of a computer's central processing unit on a single integrated circuit. That means that microprocessor, it's just a single unit component. It's a circuit that combines everything there, and you call that one a processor. So it's a computer processor that incorporates the functions of a computer's central processing unit on a single integrated circuit, just single, or IC. The microprocessor is a multi-purpose programmable device that accepts digital data as input, processes it according to instructions stored in its memory, and provides results as output. It will accept those instructions in the form of digital data as input. Then it processes them according to the instruction given, stored in its memory, and it provides the result. So, in other words, microprocessor, it is the one that is working upon items of data. It is the one in charge of working upon items of data. It is a multi-purpose device. When we say multi-purpose, it means that it can do several kinds of processing. Several kinds. And being a programmable device that accepts digital data as input, coming from maybe memory or from the outside world, but of course they must be in digital form. Then it will process according to the instruction stored in its memory and provide results. Results are provided as output. The integration of a whole CPU onto a single chip or on a few chips generally reduced the cost of processing power, making the processor a single chip. It reduces the cost of processing power because you don't need to purchase several other items. You don't need to purchase that you have to buy this one, but they combined it together to make it a microprocessor. Because initially a processor was combining several other components which were purchased very expensively, and making also the machine to be big because you needed several. But right now you combine several components and make them smaller so that you can put them in a single device, and you call it a microprocessor. And it is called a microprocessor because it is used in small computers. Now let's look at the microprocessor capacity. Microprocessor varies in capacity. So it says the capacity of microprocessor chip is represented in word size cells. Which word size that the processor can or how many words that microprocessor can process at a go. How many words? Like get an example of your mouth. How many spoonful you can chew at a go? Usually 1 spoonful. On a rare occasion, someone can add, but we expect a mouth of an elephant, you can't feed it using a spoon. For it will require a larger amount. So that size is different. So a word size is the number of bits. Example 8 or 16 or 32 or even 64 bits that a computer CPU can process at a time. That is the word size. Which word size? So word size can be represented in bits, or which you can say this processor can process 8 bits at a time, or 16 bits at a time, or 32 bits at a time. But also there is 64 bits. They call it 64 bits processor. Now, then, if a word has more bits, the computer CPU is more powerful and faster. For example, a 16-bit word computer can access 2 bytes because we learned that 1 byte is equivalent to 8 bits. So 16 bits, it means has 2 bytes. So 1 byte the same as 8 bits at a time, while 32-bit word computer can access 4 bytes at a time. Therefore, the 32-bit computer is faster than the 16-bit machine or computer. Now, when we talk again of central processing unit, we say the central processing unit is the computing part of the computer that interprets and executes program instructions. It interprets. To interpret is to make instructions clear to other components, and to execute is to process or to work upon those instructions. It is also known as the processor. The CPU is also known as the processor. In a microcomputer, the CPU is contained in a single microprocessor chip that we are talking about within the system unit. Therefore, the CPU has two parts: the control unit and the arithmetic and logical unit. These are the basic parts. There are other parts, but in the actual processing, we understand of these 2 major parts, which are control unit and the arithmetic and logical unit. They are the one working closely to each other. Of course, there are other parts we looked at, but these are major parts. There are 2 important architectures of a computer processor. Here we are talking of architectures. Please pay attention that you say there are 2 important architectures of a computer processor, of which one is CISC or CISC, complex instruction set computing, and another one is RISC or reduced instruction set computing. And be keen, at times they may ask you to write CISC in full. We'll simply say this one stands for complex instruction set computing, and this one stands for reduced instruction set computing. And this one, we are trying to look at the architectures of a processor. Two possible architectures of computer processor. Now, we say, let us look at the CISC and the RISC. 6 chips, which stand for complex instruction set computer or computing, is a computer architecture that has large sets of instructions. That's what they say, complex. It has large sets of instruction. So 6 machines have several hundred instructions. Several hundreds. It has large. Call it complex. So An example of it is the Intel's Pentium that uses 6 design. You get it? Now, RISC stands for reduced instruction set computing. While this one is complex meaning that they are large, they are many, they are large. RISC, they are reduced instruction set computing. So it's a computer that executes a few number of instructions. So in RISC, most programs generally use only a few instructions, and this architecture has a small number of instructions built into the circuit, and if those basic instructions are made to execute, they are made to execute faster, then RISC computers increase performance. That means the best architecture of the two is the reduced instruction, and not the complex, but the reduced instruction is better because they combined several instructions that could have taken time when you are working into one, so that when a command is issued, you don't issue it in following several steps. It's a matter of one instruction and the rest is understood on what to do. It's like pressing a button and you find a lot of things are done, or in getting involved in every step. That is now different. So the RISC machine tries to make a system whereby when instructions are issued, you don't follow several steps. You simply do a single command, and several other things the machine will know what to do, and that one is called RISC, or reduced instruction set computing. With that, we shall proceed with the other small subtopic known as input devices. Please keep on reading, watching over and over after copying the notes. Read, go back and watch again and again, so that you can easily understand these concepts. This the better way of understanding, especially when you are learning in a digital form. You watch more than once. When you are relaxed, you watch again and try to attempt questions, because questions will be following this tutorial. Try to always attempt the questions, and the best way you can benefit in virtual learning, you can benefit a lot actually than even in physical learning, but do assignments. We treasure this method of learning by able to repeat the content at our own pace, because we have different pace of learning, something that a teacher in class cannot do. The teacher there can only teach you once, but here you are able to play the material until you understand. But keep on doing assignments from PECO. These assignments will be ever available, even during holiday times. Remember, the material available for primary schools, for O level and A level. That means when you reach at A level, still demand for PECO material. Thank you very much. I wish you well at this particular time.